Well, hello, Scrappers. Mike here. Welcome back to my channel, and welcome to part two of working with the palladium-coated e-waste that Joven in Taiwan has sent me. Back in part one, just to quickly recap, I'll put a link in the upper right. You can go check it out, part one, if you haven't seen it. Joven wrote me and asked me if he could send me some of this stuff, and all he wanted in return was if I could figure out a process for recovering the palladium from it. So back in part one, I started experimenting with this stuff. First off, to determine whether there actually was any palladium in it. And I think I got pretty lucky in part one because I figured out a way, kind of by accident, for removing all the palladium from the 100 grams of test material I did. I did 100 grams worth. Just put this in dilute nitric acid, figured out that there's like a three-layer metal plating on it, copper on the bottom, fairly thick copper, then looks like nickel, thin coating of nickel, and then over that a thin coating of palladium. And the nitric acid ate away the nickel and some of the copper, and all the palladium just floated off free, and I was able to just capture that on filters by washing the material afterwards. So that worked out pretty well. The only chemical I needed was nitric acid, and I didn't need a huge amount of it either. So that worked really great. So I've got all of the palladium that I got in my first initial test run on that first video here on the filters in here. I took some of that palladium metal and I dissolved it in nitric acid, which is what this is, and I did a stannous chloride test on it. Got a really strong indication for palladium, so we are working with palladium. So kind of like job done. Okay, yeah, okay. Joven asked me to figure out a way to get the palladium off, and well, I've done it. Well, I think it was kind of an accident the first time around. I want to make sure it's repeatable, and I want to try and improve it a little bit because there were some problems the first time around. So I'm going to try and improve it. And of course, when the video came out, there were suggestions, as there usually are, which I'm very happy to receive your suggestions. Thank you. Keep them coming. Sometimes you guys have really great ideas and insights out there. And of course, the one I was expecting to get was, why don't you just burn this stuff? Well, okay. Couple of problems with that. First off, I've done a small test with burning this. I've done a lot of stuff off camera. I usually do before I start filming it, just so I don't look like a complete idiot. I mean, why look like a complete idiot if you can look like an incomplete idiot, right? So, I'll show you something here. I mean, there are a couple problems with burning stuff, which is always everybody's first suggestion. Yeah, burn it, burn it, burn it, burn it. Well, whatever the substrate is, it chars, but it doesn't burn away. And it leaves, we're not actually much further along than we were. Now, I could crush this now somehow through some sort of crushing operation, and the metal plating does peel off kind of nice, but we're going to have to separate it from the substrate, which chars but doesn't really burn away. I think it must be some sort of fiber thing. It's not plastic. It's some sort of maybe glass fiber reinforced because it just chars. The metal does peel off, which is kind of convenient, but in a way it's kind of inconvenient too because you've actually got to kind of manually separate it from the char, which is difficult. Besides, it produces a lot of nasty smoke when you burn this stuff. And Joven, I don't know how much you know about Taiwan. I don't know a lot, but I know it's a pretty densely populated country. Return address on Joven's package he sent me. He's in a pretty big city, okay? So unless he takes his stuff out into the countryside somewhere, he's not going to be able to burn up, kilos and kilos of it and make lots of dense black stinky smoke. That'll probably get him in a lot of trouble with his neighbors and the authorities. So, even I, who live in a fairly rural area, have to be a little bit furtive when I'm like incinerating IC chips or something. It just, not do it when there's a lot of people around so nobody calls in a complaint. So I don't see that as a viable option for Joe, and I could be wrong, but it just doesn't seem like that's going to work to me. It's not the best way of doing things. Let's put it that way. So I did come up with something that worked in that first video. I'm just going to try and improve it. But I think if I just chop this stuff up into smaller pieces and stir it a lot during the process, liable to get much better separation of the palladium layer from over the top of the copper after the nickel's dissolved out. Because the one problem I had the first time around, and it really wasn't that big a problem, I would say 99.9% of the palladium came off these, but some of it was still stuck on there. And I think it's just because I used these long strips, some of which are 6, 8 inches long, and they were all spaghettied up in there, and the liquid couldn't get in good. But if I chop them up into a lot of little pieces and keep the liquid stirred during the process, I think this will work much better. Some of you have also suggested using cold dilute nitric acid, or at least not heating it as much. And that's not a bad idea. Your logic is that the nickel and the copper are still going to dissolve in the cold dilute nitric acid, but the palladium is much less likely to. So good idea there too. And I think between that and stirring and cutting the strips up, I think we might get a much better yield. At least it's worth a try. And I want to try and do enough this time that I have enough palladium metal that we can actually try refining it, because it's coming off contaminated with a lot of stuff. There's bits of substrate in it. There's some copper. There's probably still some nickel. Who knows what else is in it? But it's dirty palladium for sure. Not something you just want to take out back with a torch and try to melt down into a beater, a button, because it's going to be really contaminated with stuff. So I think we're going to have to refine it. So I think we're going to stay away from burning this stuff for now. Sorry, all you folks who are, in Beavis and Butthead mode out there and want to see some fire.
Cool. Fire, 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 fire.
But yeah, we're gonna stick with chemical and mechanical methods here and stay away from the fire for now. Now, when that first video came out, several people suggested that I should try Eco Goldex. And Eco Goldex would probably work in this application, but I know it can be difficult to get in some places, and I'm not going to assume that Joven can get it in Taiwan. I don't know if it's available there. So I'm looking for something easy and without a lot of steps, and there's a lot of steps involved with doing Eco Goldex. There's a lot of moving parts there, but in the first video, I came up with a way to get the palladium with just using one chemical and a couple of simple mechanical separation techniques. So, we'll stick with that and not delve into something as complicated as Eco Goldex, especially since I don't even know if you can get it. Okay, so let me get to chopping this stuff up. It's going to take a while to accumulate a fair amount of it. So if you didn't see part one, which I do encourage you to go do, the link should still be in the upper right. What Joven sent me is these strips. It's like very flexible circuit board material, very thin, that's plated on both sides with palladium. And it looks like under the palladium there is nickel, and under the nickel there is copper. So they're very thin, but some of them are quite long, like this one. And they just don't play nice together in the beaker. They turn into a big ball of spaghetti, and not all of it, gets exposed to the acid. So what I'm going to do is I'm going to cut these up into strips. I'm going to try and keep them, an inch-ish long strip. And I'm not going to be too anal about it. I just want them to lay down nice in the beaker, on the bottom of the beaker, so that I can stir them regularly and make sure everything gets exposed to the acid. So it's going to take me a while. I did 100 grams in my initial test, and well, it takes a lot of these strips to make 100 grams. Joven sent me 2.5 kilos of this stuff, but each individual strip is pretty darn light. It takes a lot of strips to make 100 grams. So I'm probably going to try to aim for 2 or 250 grams. So I'm going to be cutting strips for a while. Yeah, there's times like this I wish I had some sort of paper shredder that I could feed this stuff into. But I'll get it eventually. I don't spread it all over the countryside here, which I don't want to do. So I'll work on this, and I'll be back when I've got a respectable amount of material to work with. Well, here's something interesting I found as I'm working away chopping stuff up. Joven said that these strips had originally been gold plated, and I could not figure out how they got the gold plating off without taking the palladium off too, because just about anything I could think of that would take gold plating off would take the palladium off too. But I found a couple pieces in here that do appear to have some gold plating on them still. So I guess Joven was right about that. Somebody suggested in the comments of the first video that maybe they used the reverse electroplating to get the gold plating off. I guess that's possible. I don't know why they stopped with the gold and didn't go for the palladium too, but hey, that's just a bonus for Joven and for me. So, yeah, so some of these pieces do have at least traces of gold plating on them still. So that's interesting. It's gonna make it's gonna make recovery of the palladium a little problematic if there's gold polluting it. It's kind of weird to talk about gold as a pollutant, but it's gonna be in a much smaller, tiny percentage compared to the amount of palladium here. But we'll see. I'll just give it a shot, and see what happens. There's not much gold here, so at least not much that I've seen so far. But I've only just basically got a good start on cutting this stuff, so we'll see how much more I see. Well, I found a kind of lazy way to do this, although I think like a paper cutter would be very helpful, like this kind. I used to have one of those, but darned if I can find it, because it would come in really handy for this. But what I found is these strips are all different lengths, and I can just pull the shorter ones out of the pile here every time I pull a pile out of the bag and just throw them right in the beaker. Some of them are going to be considerably longer than I was planning, but that's okay. I think they're still all going to fit in there, lay flat, and get the liquid around them. And then I just grab a handful of the longer strips and cut them. So I think I'm making much better progress this way. It's saving my scissors, it's saving my cutting hand, and I'm making good progress. I think I'm almost up to 250 grams, which is my target for this next test run. So let me finish with this, and then we will move on. Okay, my target was 250 grams. My scale says 254, but my scale is very flaky. Yeah. I need to replace this thing. All right, do I believe it? Okay, now it says 250. Okay, I'll put some of these back. I'm just trying to get the weight accurate so that we can figure out a yield on palladium down the road. Okay, so I've already done 100 grams. Here's 250 more. Hopefully we'll get enough palladium out of these two runs that we can refine it and actually get a weight on it. That's what I'm hoping. So, okay. Let me get this stuff back in a beaker. Actually, I may want to transfer this to an even bigger beaker. Yeah, that's probably not a bad idea. I might want to transfer this stuff to a bigger beaker so that wider bottom, so that the chemical will have a better chance of interacting with everything in there. So let me go dig up a bigger beaker. I'll put these in it, and I'll meet you in the fume hood, and we'll get started. All right. I got this stuff in one of my big 3-liter beakers. I think that's much better. I think I'm going to stir this much better in a 3-liter beaker and make sure hopefully everything gets in contact with the acid. I mean, it's amazing how well it worked before when it was all just a big ball of spaghetti. So hopefully this will work even better. Whoops. Something went flying off into the back of the fume hood somewhere. Oh well. That one little piece won't affect the weight any. Alright, so we're going to do exactly like I did last time with the changes of we got smaller pieces in here and we're not going to put the heat on. The burner is off on the hot plate. We're doing this inside the fume hood just to contain the fumes that are going to be developed. So just like last time, I'm going to cover all this stuff with some distilled water. All right. And just like last time, I'm going to put some of my homemade nitric acid on it. I have a video on how I made this acid. I'll put a link in the upper right. So what I'm going to do is I'm going to put a little in. Actually, I'm going to put a little more than a little in because, well, we've got a lot of material here. And look at the immediate strong reaction we're getting. Look at that. Let me get the fume hood going. Yeah, immediate strong reaction. All right. So we're just going to let this sit cold and do its thing. All right. And, well, the reaction's died down already. That's interesting. But notice that the liquid is turning green. I do believe we are dissolving nickel. Now, this is cold, but cold is a relative term because it's summer, it's Central Florida, and it's right around 90 degrees out here right now, so it's not super cold. But, we'll put a little more in. And I'm just going to let this sit now. The goal here is to dissolve away the nickel underneath the palladium until the palladium is free, but not to dissolve the copper underneath the nickel, because if all the copper goes away, the palladium will start going into solution, and we don't want that. So this is going to be slower since I don't have it on the heat, but I'm just going to let it sit. If it takes a day or two, it takes a day or two. It takes a week. It takes a week. I don't know. I don't care. But what I want to do is I want to dissolve all that nickel under the palladium, and that should free up the palladium. As long as there's still copper underneath the nickel, that will react with the nitric acid preferentially over the palladium. Any palladium that does go into solution will immediately cement back out on the copper. So what I had the first time around was just a trace of palladium in the liquid, which was mostly nickel and copper nitrates. So, okay. Without the heat, this is going very slowly, but we're going to let it go. And I will be very careful with my additions of nitric acid from here on out. I've put a fair amount in. There's a fair amount of material in there, but I put a fair amount of nitric acid in. The reaction's slow, but we may get there in the end. I don't want to put in too much nitric acid and wind up dissolving away all the copper. The liquid's green right now, so that tells me we haven't even started dissolving copper yet. When this liquid goes blue, we'll know we've started dissolving copper. So, just let it go. Well, it is the next day. In fact, it has been about 24 hours since I started this project, a little over 24 hours. And I was a little worried at first because when I shut the lab down last night, this was still fairly light green and didn't seem like there was much going on. I've not put any more nitric acid in it. And I let it sit overnight. I came out here this morning and had a quick look at it. Just had to be a quick look because I was on my way to work. And it had turned blue, and I was starting to see little fragments of palladium floating around in it. And now it's the afternoon of the next day. Just got home from work, and I'm looking at it. And, yep, a lot of the palladium has come off. I still see a fair amount that has not come off. I'm a little on the fence about whether I want to put more nitric in there or not. I'm thinking at this point, maybe not. Maybe just give it a good stir here and let it sit till tomorrow and then make a decision if it doesn't look like a whole lot more of the palladium has come off. Um, I think that's what I'm going to do. Maybe I'll stir it one more time before I shut down for the night. But it looks like it's working. Just no heat. It's a little slower. The heat definitely speeds things up. But we may be getting by with less nitric though, too. Um, so yeah, I'm just going to let it run as is, and we'll get another look at it tomorrow morning and make a decision about where to go from there. Does it need more nitric or not? Or if I get tired of waiting on it, maybe I'll crank the heat up and see if that'll finish it. All right, so we'll wait until tomorrow. Well, it's the next morning, so it's been not quite 48 hours yet, and we are still going here. No heat, no more nitric acid. I'm not really seeing much of a difference from last night. I think maybe the reaction has stopped. I still see some strips with the palladium on them. I mean, there's a lot floating around in there for sure. Floating around free, but I think there's still some connected to the strips. So I'm going to put a little bit more nitric acid in it. Not too much, just a little bit. And let it do its thing for a little while longer. I see a lot of free copper in there, so I'm not too worried about over nitrating it, but I am going to put only a small dose in. Now, a lot of people have suggested that AP solution would work. And yes, I think AP solution would work on this. It works on gold. It gets gold off. It's slow. But with a bubbler for agitation, like from a fish tank bubbler, I think AP solution would work in the long run. It might take a few days, a few weeks even, depending on temperature and other factors, how well it's aerated and whatnot. I think AP solution would work pretty well for getting this stuff off. Now, overnight, Joven saw the video, the first video, and he emailed me. And he's very happy with the video. Very glad to see it. He did mention AP solution, though, and said that he's had spotty luck with it, maybe not removing all of the palladium. But again, that just might be a factor of time. I mean, AP solution can be slow. Sometimes you got to let it go for a very long time. He also said that he was glad I didn't incinerate the stuff. The incineration is really not something he's interested in trying. So yeah, so all of you folks who say burn it, burn it, burn it, fire, 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 it's not something he can do. So we've got to find other methods. Now he did suggest, since he's had trouble with the AP solution method, to just try and dissolve all of the metals off and then pull the palladium back out of solution. So we may try that in a future video and see how that works. Just see if we can come up with a method for him to do that. Might be able to cement it out on copper. That's a possibility. If we were to dissolve all this stuff in nitric acid, maybe we could cement the palladium back out on copper. We might try that in the future just to see. But I think we're going to run this experiment to completion and not have like an M. Night Shyamalan twist in the middle of it where we advertise it as one thing and then do something completely different in the end. So, all right. I'm going to let this run. I'm going to take another look at it this afternoon, this evening, and see how it's going. And hopefully, in a day or so, it'll be done. And we can separate the palladium out. Okay. Just going to let it cook. Well, not cook. There's no heat. Just ambient. But it's working. We're just going to let it go. Okay, it's evening again. This has been going all day. I see a lot less palladium stuck on the pieces. I've come out and stirred it a couple of times because I've been off work today. But otherwise, I haven't done anything to it since I added that last shot of nitric acid. But I'm thinking I mean, I see a lot less palladium stuff on there, but I do still see some. So I'm thinking I'm going to add another shot of nitric acid to it. I mean, this is working. It's just a little slow. I don't think it's as slow as AP solution. AP solution would probably be cheaper than spending money on nitric acid for sure. But the nitric acid is quicker. Let me give this another good stir to distribute that acid. We'll let it sit again overnight. And that one's still got some palladium on it. I mean, there's a lot of palladium floating in there, but there's still some stuck. Now this is kind of working, I think, like AP solution too. I've not put nearly enough acid in there to dissolve all that metal. But with AP solution, once you get a little bit of the metal dissolved in solution, those corrosive metal salts help corrode the rest of the metal off pretty quickly. So I think that's kind of what we've got going on here. I'm not using that much nitric acid, but I'm getting a pretty good result, I think. Yeah, we're definitely getting there. So we'll let this sit one more. I'm going to work tomorrow, so it will probably be tomorrow afternoon before I can look at this again and see how it's doing. I'll try to give it a stir in the morning before I leave, and then we'll check it out tomorrow afternoon. I'd say we're definitely getting there. Most of the palladium seems to be off. There's still just a little bit of stubborn stuff there. Let's see if we can get that free. All right, I would say this stuff is done. It's actually a couple days since I filmed the last segment. This stuff's mostly just been sitting here because I've been really busy with other things, mainly work. Um, Came out the other morning, looked at it, thought, you know what, this looks pretty done. And stirred it around, came back, looked at it again after work the next day, and it's like, yeah, it looks done. I haven't added any more nitric acid to it. Just been sitting here. And, well, it's Saturday, and I've got some time to deal with it. I see areas where there's still a little bit of palladium that looks like it's still attached, but most of it I see looks like it's just sitting there, floating around. I'll give you a look inside the beaker here, see if I can do that. So here's kind of what I'm seeing in there. Mostly copper that's left on the strips. There might be some small areas of palladium, like maybe right there. Yeah, that looks kind of silvery. But I'll tell you what, most of these strips really look like they've had it all removed, and it's just floating around in here and sticking on them at times. Like this stuff over here. This looks like it's stuck on there. All right, let's move on with this process. Look at it all floating around in the liquid, though, when I stir it. There's a lot of palladium oil in there. All right, so let's move on. All right, so I'm going to deal with this like I did last time. Basically, what I did last time was I just filtered this blue liquid off of the strips and caught all of the floating palladium on a filter here. I'm going to do that. And just like last time, I'm going to rinse these strips a few times with some distilled water. I want to get this blue liquid containing a lot of copper and nickel. I want to away from the palladium. I want to separate that from the palladium. This alone is going to make the palladium a lot cleaner. Okay. And I will rinse these strips a few times and dump the rinse water through the filter because more of the palladium metal is going to come over. And then we'll go to my favorite mechanical separation method to get the rest of the palladium away from the strips. But the filtration is going to take a little while, so we'll do that first. And I'll be back when that's done. Also, we're going to test this liquid with some stannous chloride solution and see if we've got any palladium in solution. Last time there was just a little trace of it, it seemed like. And I put this liquid in my stock pot. We'll probably end up doing the exact same thing this time, just to make sure we don't lose any palladium dissolved in the liquid. Alrighty, I have rinsed this stuff and drained the rinse water through the funnel. Got, it looks like a fair amount of the palladium came over. Let's see if I can give you a look at that. Gonna darken the funnel. But as usual, a fair amount of the palladium came over. A lot of other stuff did too, unfortunately. So yeah, it's some pretty dirty palladium, but we'll make it cleaner. I think later in this video we'll figure out a way to do that. We'll make the palladium cleaner. All right, so next I need to separate the rest of the palladium from these strips in here, and we're going to do that the same way I did it last time with my colander and bowl method over here, and I'll show you that in a second. Okay, so just like before, we're going to put this stuff in the colander. Ooh, it's getting very windy. It might storm later today. And the idea behind this process, which I use with gold fingers a lot, and it works pretty well with gold fingers, is that the strips are too big to go through the holes in the colander, but the little bits of palladium go right through. So this is a good way to separate the palladium from the strips. Now I need to separate the palladium from my fingers after having my hand inside the beaker there. A lot of palladium on my fingers. Let me get all the palladium out of this beaker. There's some stuck to the sides. Everybody in. No laggards. Nobody gets to stay behind. Mandatory. Alright, so that's looking pretty good. We're going to add some extra water to this. Bring the water level up, like so. So everybody's swimming in the pool here. And we're going to agitate this. And palladium's going to go through the holes, and the strips are going to get cleaner and cleaner over time. This works much better with gold because gold is considerably denser than palladium, so it tends to sink really fast and go down through the holes. The palladium, not so much. It likes to stay floating in the water column, so this takes a little while. What I'm going to do is I'm going to pull the strips out a few at a time here. Rinse them off in the water. And then set them aside. And I can see I'm pulling a little bit of palladium out. But not too much. Wash a couple of these a little more. Yeah, okay. So this just takes time. It's easier with gold, like I said, but the palladium, being so much less dense, it just wants to hang around in the water. But eventually, we'll get it all through the colander and down into the bowl there. So I'll just keep working at it until I'm done. Okay, I'm done rinsing the strips. I'll give you a close-up look at them. They're pretty clean. I see a few little specks in there, here and there, of palladium still, but they're pretty clean. And I really didn't see any still stuck on the copper, like it hadn't been dissolved, like the underlying metal had not been dissolved off. All the palladium in there was just foils laying on the copper, so that's good. It went better than I expected. Okay, well, the strips are pretty clean. If you look close, you'll see a little specks of palladium here and there. There's some there. There's some there. I would say we got 99.99% of it. I think the only way to get all the palladium out of this stuff would be to dissolve all the metal, which is one idea Joven had. Dissolve all the metal, all the nickel, all the copper, all the palladium, and then try to precipitate the palladium out of it. That's something we might explore in another video. So stay tuned for that. But I think we're doing pretty good with just these methods, in case, you know, Joven can't get a hold of enough nitric acid to do the whole thing. So, all right, let me filter this liquid and catch all the palladium in the bottom of this bowl. I'll give you a look at it once I get some of this dirty water off of it. It's hard to see down there, but it looks like there's a lot of solids in there. So all our palladium, 99.99% of it should be in here, plus what's in that filter over there. So let me get set up to filter this rinse water. I'm going to filter it and catch all the palladium in here in a filter too. We'll have 2 more filters. That'll give us a total of 4, counting the filters from last time, full of palladium metal foils. So that should be enough to process, hopefully, and get enough palladium to actually weigh. We'll see. So let me clean up my mess here and get set up to filter this stuff. All right, before I can filter all the water in this bowl over here, I've got to deal with the liquid from the first filtration. So this stuff might have some dissolved palladium in it, so I want to do a stannous chloride test on it and see if we've got anything. Some fresh stannous chloride here. Let me zoom in on the spot plate so you can see what, if anything, happens. Get a good focus. Oh yeah, okay, so there was a trace of orange there as I put the stannous chloride in. I don't know if that showed up. Now the liquid is already kind of blue-green, but it's gone green after putting it in. But the trace of orange tells me, yeah, there's a little bit of palladium dissolved in this liquid over here. I'd have been surprised if there wasn't any. I mean, after all, nitric acid does dissolve palladium. There's probably some sort of equilibrium going on in there, with palladium going into solution and then copper pulling it out again. So it's a low level. It's not a lot, but I'm going to put this in my stock pot rather than in my waste bucket. And someday in the future, when I process my stock pot again, like I did in the past, I'll put a link in the upper right to the last time I processed my stock pot. Got some palladium then? Well, I'll get this palladium back then. So, okay, so let me dispose of this, and we will get to filtering the stuff in that bowl. Okay, let's get this stuff filtered. It sat and clarified a little bit. I can see how much solids there is in the bottom of this. There's a lot of solids in here. That's good, because most of that solids is going to be palladium. There's going to be a little bit of copper that's flaked up. I see palladium foil floating in here already. You know, there's going to be a little bit of copper that's flaked off, some bits of the substrate, some miscellaneous crud. But really, there's a lot of palladium there. You see it shining? Shiny little bits in there. Yeah, there's a lot of palladium there. Excellent. So it's going to take me a while to run all this liquid through the filter up here. It'll clog up fairly quickly. Don't feel like getting my vacuum filtration set up out for this little bit of material. But I'll give you a look at the last little bit before it goes through the filter and show you how much palladium's in there. It's impressive. Okay, so we're down to the last little bit here. I hope all that palladium foil down in there is showing up. I get a good focus on it. Try to anyway. So there's a lot of palladium foil here. I mean, it looks like there's a lot of crud there too, but I tell you what, I'm having a little second thought on that. I'm thinking that that black crud in there might just be small bits of palladium foil. I mean, finely divided metal tends to look black, so it's possible we got a fair amount of palladium here. So once the water in the funnel goes down, I will dump that stuff in and capture it, and then we should have all of our palladium in this filter and these filters over here, and we'll be ready to move on and do something else with it. So I'll be back when this is in there and drained. Okay? Wow, check all that out. That looks like a lot of palladium foil. I'm sure it's not going to amount to much weight-wise, but it's an impressive looking pile of palladium in there, for sure. Okay, I'm going to let this finish dripping until it's good and dry, and then I will put this filter in with the other three, and we will move on to further processing. Alrighty, I think it's time to get the palladium in these four filters into solution so that we can purify it, get it away from whatever crud we've also caught on these filters. So putting it into solution, we've got a couple of options. We could do aqua regia, or we could do straight nitric acid. So what do I want to do? Well, I've already got some dissolved in nitric acid, and that went really smooth and easy. So I'm thinking I'm just going to dissolve the rest of this stuff in nitric acid, use as little as I can, and we'll denox it. I'll add this stuff to it, then we'll denox it and filter it with a nice clean filtrate, hopefully that kind of looks like this stuff, and then see if we can cement the palladium out on copper. That sounds like a pretty good idea to me. It's not going to be the purest palladium in the world, but it's a quick and easy way to do it. We can explore more thorough refining in the future, possibilities there. But I think this is a good way to go for today. So I'm going to start by putting some distilled water, cover the filters, just enough to cover them, maybe a little more. It's probably going to be enough, especially once the filters start falling apart. We'll poke a few holes in them with the stick here. Let's put a little bit of nitric acid on them, but I think I'm going to be more conservative with the acid rather than just pouring it in like I was before. We're going to use a pipette, and we're going to put in, well, there's about 3 milliliters. There's not quite 6 milliliters. Try not to spill it. There's almost not quite 3 more milliliters. There's a good healthy 3 milliliters right there. So that's close to 12 milliliters of acid. We'll leave it at that and see what that does. Okay? And I'm going to put a little bit of heat to this to try and speed the process up. Not a lot, a little bit. And also, I said I was going to add this stuff to it, which I need to do. To get the fume hood going, because I see fumes developing already. Put this stuff in here. That's the palladium that I dissolved in liquid in the first test in order to test whether there actually was palladium there. And was pleasantly surprised by the fact that, yes, there was palladium there. So we're just going to let this cook. I'll check it from time to time, stir it, and see how it's going. I'm expecting a lot of that palladium to go into solution just with the 12 milliliters of nitric acid I put in there so far. Maybe not all of it. I'm hoping that the paper breaks down too, and that'll make it easier to see if all the palladium's in solution. So we'll just let it go and check on it from time to time. Well, it's only been a few minutes, not long enough for me to clean up the bench over there, and this stuff is starting to turn green. So why green, you might be asking? Well, it's more of a yellow-green, I think. So probably the yellow of the palladium going into solution and blue from the copper residue in there. And as the commercials say, yellow plus blue makes green. So I think that's what's going on. I figured we'd have some copper contamination. But since I'm going to cement this stuff out on copper, I'm not too worried about it. So the green color of the liquid tells me something's happening anyway as it warms up. Yeah, it's getting warm. Alright. I don't know if that was enough nitric acid or not. I'm not really seeing any fumes. I see a lot of palladium still floating around in there, but I'm going to let it sit for a little while before I add any more. And we'll see what happens. Well, I do believe the liquid is getting yellower as more of the palladium goes into solution. I'm certainly seeing a lot less of it floating around in there. I still am seeing some palladium flakes. I have not added any more nitric acid yet. So, palladium's definitely going in solution. I may need more, but so far I haven't had to add it. So let's let it cook a little while longer and see what happens. Well, the liquid's gotten very intensely yellow, and I don't see any more floating palladium in there. The filter papers are falling apart. I do believe all the metal's in solution. So I guess I put enough nitric acid in there. Question is though, did I put in too much nitric acid? So I've got a saturated solution of sulfamic acid here. I'm going to use this to try and denox the solution a little. Is it important to denox it? I'm not certain in this case. Am I going to do it anyway? Yeah, I think so. So let's see what happens here. Oh yeah, there's some excess nitric acid in there. We've got some reaction as I pour the sulfamic acid in. This is going to destroy the excess nitric acid. Ooh, there's a fair amount of excess nitric acid there. Okay. All that sulfamic acid in there. Alright. That is probably denoxed enough for the next step. I'm going to cement this stuff out on copper, but I need to filter it, get all this paper gunge out of it, all that brown and black stuff in there out of it. But I do know I need to let it cool down. I don't know if denoxing it was important, but letting it cool down before I filter it certainly is. Or this solution will destroy the filter paper just like it's destroyed the paper in there. So we're going to let it cool down, and then we'll set up to filter it. Okay, this stuff's had a chance to cool down, so I'm going to filter it. Got my ridiculously large Buckner funnel out. We're going to do vacuum filtration because I want to pull every bit of palladium goodness out of this soupy stuff here. We got a lot of paper pulp in there, but I'll show you why I want to get it all out. Let me do a stannous chloride test on this. Get some liquid here and not just pulp. Okay. I got some fresh stannous chloride here. Let me zoom in on the spot plate. I think you'll be impressed. Look at that. Look at that color. Looks black. You would think that's a very strong gold indication, but it's not black. It is such a dark green. Such a dark green, it looks black. So, yeah, we've got a really strong indication of palladium in this stuff, but I knew there was going to be a lot in it because I saw how much metal was in there and got dissolved. So, yeah, okay, we got a lot of palladium here. Let me get this stuff filtered so we can see if we can recover it. Before we get on to filtration, here's a little piece of paper towel I used to clean out the well in the spot plate down here. And you can see the green color on it. So, yeah, it just looked black on the spot plate. So this is going with my filter and rag storage for when I process them to get the precious metals out of them. All right, let me finish cleaning up and we'll get to filtering. Okay, let's get to filtering this stuff. My vacuum pump on. So I'm going to dump this stuff in here in the Buckner funnel. Let the vacuum pull the liquid through. And I'm going to run a lot of rinse water over the solids in here to see if I can extract as much of the palladium goodness as I can from it. I definitely want the rinse water to be running clear. Make sure I get it all out of the beaker. Yeah. Good. Spread this out a little bit and I'm going to drench it with a lot of rinse water and let the vacuum pull the palladium salt out of it. So you can still see it's running green. So I'm just going to keep this up until it's coming through clear. So, be back when we're done. I've run a lot of rinse water through here. I'm going to let this just drain now. Let the vacuum pull the rest of the moisture out of everything up there until it's good and dry. Now, in spite of my best efforts, I'm sure I haven't got all the palladium out of these solids and out of the filter up here. All this is going to go in my filter and rag storage for future processing once it's good and dry. So, just going to let this run until the dripping stops. Well, here it is, our nice clean palladium solution. All right, so next step is to try and recover the palladium from this, but this video is getting kind of long. So I think we'll do that in a future video. In the meantime, I would like to see your comments down in the bottom of this video on what you think the best way would be to get the palladium back out of this stuff. Now be mindful of the fact that it was dissolved with nitric acid, not aqua regia, and it's probably contaminated with a fair amount of copper. So keep those two things in mind and give me your best guess as to how you think I should get the palladium back out of it. And subscribe to see future videos where I'm working with this stuff and the rest of Jovan's stuff. I've only just started with Jovan's stuff. I've got a lot left. I'm thinking I could scale up and do the rest of it in a future video. So, subscribe to see that and all the other videos I'm going to do in the future. I'm going to be refining the palladium, whatnot. And check out my two other channels, Electro Geek 64 and Mike's Lapidarian Fossils. I think you might find some interesting stuff there. And I'll see you in the next video. Thanks a lot for watching this one. Bye.